Hello students, I am Dr. Shailaja Jadhav, Professor and HOD in Department of Pharmaceutical Chemistry at Progressive Education Society's Modern College of Pharmacy, Nigri, Pune. In this part 1 of Introduction to Antibiotics, we shall see the introduction including the history of antibiotics in short and classification of antibiotics. What are antibiotics? Antibiotics are the substances obtained from microorganisms which are toxic to other microorganisms in small quantity. Antibiotics are selectively toxic for the bacteria and they do not harm the host. They are either bactericidal or bacteriostatic. Bactericidal means they kill the bacteria and bacteriostatic means they inhibit the growth of the bacteria. Now, antibiotics are more efficient in fighting the infecting bacteria if the host immune system is good. I doubt if you can find a person who has never taken any antibiotic in their lives, as antibiotics have a long history. It started in 1928 when penicillin was first discovered by Alexander Fleming in the form of a mold when he saw that it inhibited the growth of the Staphylococcus bacteria. Penicillin was first isolated in 1940 and in 1941 mass production of penicillin was done for its use in the World War II. In the 1950s, 6-APA, that is the 6-aminopenicillanic acid was discovered and the semi-synthetic penicillins were developed. Since then, till date, many novel beta-lactams and beta-lactamase inhibitors have been discovered and synthesized. We can classify antibiotics either on the basis of their chemical structure or the mechanism of action. We shall see both classifications. First, let us see the classification on the basis of their chemical structures. These classes are first beta-lactams, which include penicillins, example amoxicillin, cephalosporins, example cefotaxime, carbapenems, monobactams, oxapenems, and the beta-lactamase inhibitors like clavulanic acid. Second, tetracyclines, example chlortetracycline, aminoglycosides like streptomycin. The classification continues with glycopeptides, example bacitracin, macrolides, example erythromycin, quinolins, example ciprofloxacin, sulfonamides like sulfanilamide, lincomycins like clindamycin, and few of the antibiotics under the miscellaneous class such as chloramphenicol. Now, let us see the classification on the basis of mechanism of action. These are the antibiotics that inhibit the cell wall synthesis or which inhibit the functions of cytoplasmic membrane, or the antibiotics that inhibit protein synthesis, and lastly, the antibiotics which inhibit nucleic acid synthesis. Let us start with the antibiotics that act by inhibition of the cell wall synthesis. Now, which are these antibiotics? These are the beta-lactams and the glycopeptides. You already know that beta-lactams include penicillins, cephalosporins, carbapenems, oxapenems, and monobactams. So next, we shall see the beta-lactam antibiotics in detail. The basic structure of beta-lactams consists of a fused beta-lactam ring system and a side chain at alpha position. If you look at the various classes of beta-lactams, you will observe that they have variations in the ring which is fused with the beta-lactam ring and in the side chain at the alpha position. For example, penicillins and cephalosporins. These are the two subclasses of beta-lactam antibiotics. In case of penicillins, the fused ring system consists of beta-lactam ring and thiazolidine ring, whereas cephalosporins consist of beta-lactam ring fused with dihydrothiazine. So, we have seen introduction to antibiotics, including short history and its classification. Next, we shall see mechanism of action of penicillins in the part 2 of Introduction to Antibiotics.